Good morning, good afternoon, good evening, depending on where you are. Today is April 14th, and this is another work group batch meeting. My name is Maciej, and I'll be your host today. Our agenda is packed with 3 topics. So let's start with Aldo and Abdullah and the Q 0.1.0 release.
Aldo?
Hi. Yes. Yes, as you might know, in Scheduler we started working in this controller for job queuing, and we released our first version. This version has native support for the batch v1 job API using the suspend flag that we worked on in 123. Yeah, you can define resource sharing to do well, to use the unused resources from one tenant in another tenant, and resource fungibility, which means you can define which models of VMs or resources you want to fall back to if there's no more space. For example, the canonical use case is spot VMs versus on-demand VMs. So you can define a quota for spot, and if you run out of that quota, you can fall back to on-demand. And well, all the documentation is available in the GitHub repository, and we are very happy to accept feature requests or of course bug reports. And yeah, we are building this with the community, so we want to hear from you about what's on top of mind for you. Yeah, I don't know if Abdullah, you want to add anything else?
Yeah, no, thank you. You covered it. Like just last note, like we welcome any contributions, any suggestions how we can improve. We've got really decent documentation trying to detail the concepts, common tasks, and it would be nice if you can try reading through the documentation, make sure that it is well explained, etc. And if it fits your use case, try it out. If there are gaps, please find issues.
Okay, does anyone have any questions to Abdullah or Aldo about the first QA release?
We're also happy to demo it at some point, maybe in a couple of weeks or in 4 weeks after KubeCon.
Yeah, definitely. That'll be very valuable for sure.
Maybe a question. Sorry, I missed the beginning of the meeting, but I was willing to give this a go. So, Abdullah, what can be tried right now? I saw there are some queue concepts, and so that base functionality should already be working.
Yeah, everything documented it should be working. Like everything documented on the queue website, on the GitHub, it should be working. You can go through the tasks. Those should cover most of the functionality that that's currently supported.
And then for things that do not work, we open issues. But for things that do work, do you want also like a report of what the experience was on the good side as well?
That would be great. Yeah, any feedback would be great. If you find that, okay, this is like the way that we're defining specific things is confusing, or it's not working as expected, or it did not match your expectations. Maybe it's working as intended, as we intended it, but it didn't match your expectation. Yeah, feel free to open any issues.
right.
Everything is welcome. Everything will be triaged and try to, categorize it.
Awesome. Thank you.
Any other questions? Hearing none, okay, we can jump to the next topic, Abdullah, pod resource reservation.
Can I share my screen?
Yeah, sure. Let me stop sharing right away. Go ahead.
I'm just going to share the same document, but I wanted to.
Yeah, no worries.
Yeah. Can you see my screen?
Yes, we can.
Right. Yeah. So this is the proposal that I mentioned last time. I hope you get a chance to look at it. And if you don't, I'm just going to give a quick summary of what we're trying to achieve, what we're proposing, and what we're trying to achieve. And so the idea here is that we wanted to introduce a new object API that is like exactly similar to a pod, but it doesn't really run, like it doesn't execute, like the container in it wouldn't be started by kubelet. It wouldn't even create the the C groups or anything else. And this object API, we're naming it reservation, that basically can be created and would allow users to reserve some resources on the cluster that the scheduler and kubelet are aware of, and would allow a future created pod to run in that reservation. And the motivation for this is twofold. The first one is pre-provisioning of resources and in anticipation of spikes. For example, like if a service knows that every noon you're gonna get a spike of traffic, they can create these reservations to scale up the cluster. So imagine that you're running in an auto-scaled cluster, and auto-scaling is sometimes it's expensive, like creating the VMs and getting the node ready. But like you want to absorb that, amortize that cost, and so you would try to trigger a scale up. Currently, the way that people do it is they create pods with low priority, and then the actual workload pods that gets created, they have higher priority, and they would basically preempt the lower priority pods. The problem with this approach is that it's indiscriminate, right? Like any higher priority pod can take that pod space. With this proposal, you'll be able to make a reservation and basically label it and say, okay, this reservation can only be taken by this pod that is selecting it. And so you'll be able to say, okay, I'm gonna scale up the cluster by creating these reservations, but these reservations will exist. But if some other service tries to scales up, tries to schedule its pods, they will not take that. They will not be able, to take up that space. It will continue to be reserved for that specific, spike that you're anticipating. The second use case here is managing resource allocation of queue jobs, and this is basically, imagine it's similar to the case where we have in queue. So in queue, we are basically proposing to manage jobs, and we're doing that by managing when they should start. Now, if a job gets to the head of the queue and it gets started by basically unsuspending it, there is still no guarantee that we'll actually get the resources on the cluster, right? Because this resource manager is not a pod to node scheduler. It's not going to guarantee that the space exists on the cluster. It's just a quota manager. Again, similar to even resource quotas. the normal resource quota thing. If you have quota in the cluster to create X number of pods, it doesn't mean that those pods will actually get the resources that they want, right? But with this approach, you could imagine that this, controller would be able to create a reservation before starting the job, make sure that you get the actual resources on the cluster, and then start the job. That job would select those reservations, would run in these reservations. So those are the two high-level use cases that we have in mind. Others mentioned that it could be useful, for example, if the reservation on the node would pre-pull, for example, the images as well, which also is like an optimization. Sometimes images are so huge that are expensive to put startup times. So again, if you're anticipating a spike in traffic, it's not only the cost of provisioning the resources and bringing up the VMs in the node, but also pre-pulling the images as well. Any questions on these two motivating use cases? So the proposal here is the API is fairly simple at the initial API. As I mentioned, you've got the spec and the status, but the spec is really just a pod template. And it's basically describing what would the future pod that will take a place of this reservation is going to look like. And in the pod spec, we would have a reservation affinity. It's basically a label selector that says, when you create the pod, you will say, this pod is schedulable in place of these reservations. And so the idea here is that Kube scheduler will be aware of the reservation API, just like it's aware of pods. It needs to schedule both of them. But one thing that is special for pods with a reservation affinity is that the scheduler will, for example, have a plugin that checks if there are existing reservations that match this selector, and if it does, it will basically schedule this pod on the node where that reservation was assigned beforehand. So that is the high-level idea at the pod level. It is a concept that's similar to alloc as well, or salloc. Someone mentioned that before, and I think in other schedulers. Again, it's going to be an API that mirrors a pod, and you can think of an alternative solution here. Alternative proposal is to have what we call a fake pod, the actual pod, but you could add a mode to it that this pod doesn't run, for example. But it would it could be more complicated. Claudia?
Hi, yes. I have a question. Maybe you explained that and I didn't understand. So the reservation, is that a way is it ensured that the pod will run at some point, or can it stay reserved forever and never start? In that case, is there some timeout or something like that? Because I understand that the resources anyway get kind of assigned to that pod, even if the pod is not running, so that the schedulers see that the resources are taken already by that pod. So how would that work?
So the resources will be set aside as long as the reservation object exists and is assigned to a node. Think of it as a pod that is scheduled on a node, and think of it as a pause pod, basically, right? Like a pause pod, a pod that is doing nothing, just standing still on the node, taking up resources that the scheduler knows that is not available on the node, and kubelet as well. So reservation is exactly the same thing. And so the idea here is that you create the reservation before you create the pods that will take place of that reservation. And when you don't want that reservation, you delete it. You can imagine reusing the reservation. You create the reservation, for example, for a job. The job has like you need to complete 1,000 instances of the job, but you're doing it 100 at a time. So you could create 100 reservations. Those will stay there, and the job controller will all the time continue to make sure that you have 100 pods, right? Like every time it finishes, it completes one instance, it will recreate another pod to complete the next one. Those pods would basically be able to schedule in place of these same reservations back to back. So you would create like 100 reservation object, and then the job controller will create the first 100 pods, which will schedule in place of those reservations. And then as they complete at different points, it doesn't matter, a new pod will be created, but it will be able to take place of that reservation. Now, assume that you created only 50 reservations and you have 100 pods that select that reservation, only 50 will be scheduled and the other 50 will not, because there is not enough reservations for the other 50 that selects the reservation. Does that make sense?
Yeah, I think I understand that a little better now. So basically, a reservation is, let me pass the term, attached to an existing set of pods that are running. And then if there are more, the same spot would be reserved, would be used by the new pods once the existing ones are completed. So there is not a scenario where the reservation is created, but there is actually no job running.
No, that does exist. Like the idea is that you create the reservation before creating the job, before creating the pods, right? Like think of the reservation as a subnode, right? It's basically like a set of resources on a node that you set aside and only can be used by a future pod that selects that reservation.
So it's like a reservation, a resource reservation rather than pod reservation.
Yeah, exactly. It's a resource reservation that a pod can run in, right? Like at the end of the day, you want these resources reserved for a future pod, right? Like for something to run in it in the future. And in Kubernetes, that thing is always a pod.
Right, yeah. And yeah, so the person who is creating the reservation has to delete that at some point. Otherwise, I mean, there is no automatic way to delete, or there shouldn't be any automated way to delete a reservation that's been there since like forever, and it's not allowing other jobs to run. So that's basically 100% on the user.
That's a great question. I think the life cycle of the reservation could have a mode where you could say, okay, one mode could be never delete the reservation automatically. It should be deleted like explicitly. Another mode of operation is, for example, use once. Like if one pod uses that reservation, once that pod exits, then delete the reservation automatically.
Right.
So I imagine something like that. Like there could be multiple modes of operation for reservations.
Yeah, that would make it. I mean, I think that would be very useful to have, because otherwise you reach points where the cluster cannot be used, might not be used completely, even if node pods are running. And I mean, this is I like the connection to like bursting scenarios where you have at some point in time you think that there can be a burst of pod. So even in that case, having some automation or some way to specify a timeline, time frame where this should happen, that would make it cool, or at least that's my opinion on it.
Right. The idea here is, again, to split the resource provisioning from application startup. Like right now, they are merged into one through the pod spec, right? With this approach, you are giving some flexibility to a resource manager like job queuing to basically manage resources, but not manage the application, which is what it wants, right? Like we want to be application agnostic. It doesn't matter what type of job that will be started, but I want to manage the resources. And the way that you manage resources, you say, okay, I'm going, queue would basically create the reservation. And then by doing so, you can also implement fungibility. Like queue says, okay, this job should run on spot VMs. And so you would create a reservation with with an affinity to spot VMs, right? And so you're basically guiding the job that will start to force it to go to land on a spot VM without modifying the original job template to include these node affinities. And so this is a kind of a powerful concept. Like you when you split these two things, you're able to do you're able to control better your resources in the cluster. Yeah. And give some guarantees basically around it.
Yeah, got it. Thanks.
How can you ensure the full replaceability of the reservation pods with an actual workload pod in case, for example, the cluster is less busy? Because obviously, when you have fully packed cluster, the lower priority pod will get evicted in favor of the new one. But in a cluster which is not that busy, where you have free resources, how would you ensure that the workload is actually replacing the reservation pod?
The workload replacing the reservation.
Well, yeah, because you basically you're basically talking that you are reserving this many resources. And this applies strictly to the cases where you have pretty packed clusters. But let's assume a situation where we are, I don't know, 80–90% of the usage of the cluster. So there's still 10–20% of free resources. How can you ensure that whenever an actual workload, when it starts using its resources, it will in parallel, or the reservation in parallel will start removing the pods that were reserving the resources? How the interaction between, I don't know, let's say the job controller and the reservation controller will look like in case when one is creating the actual pods and the other one should be in response limiting the reservations or replacing them.
So so the job controller itself is not aware of the reservation controller. It has nothing to do with it. The only thing that it does is it creates the pods based on your job spec. Now, the only thing in the spec that the user could include is if I want to use a reservation, and you do that by adding this label selector, the reservation affinity. Now, we can have a number of modes of operations. We can say, okay, the schedule, and like from there, it's the scheduler's issue. Imagine you didn't have any reservations created. The scheduler sees this pod with a reservation affinity. It will say you could have that implemented as a filter. And so if there is no reservation in the cluster that matches this label selector, the pod will continue to be unschedulable and pending until someone creates the reservation. Again, like it could be like a queue, a job, like a quota manager, a queue manager, whatever it is. The pod will continue to be pending. Once the reservation is created, the reservation will first get scheduled by the scheduler. Again, the scheduler is not going to really match them or anything. It will do the same thing as it's doing right now. Schedule one entity at a time. That is going to be a reservation or a pod. It will schedule the reservation. Once the reservation is scheduled, it will pick up like the unscheduled pods. One of them is going to be This one that was previously unschedulable, now it's that filter for matching the label selector to an existing affinity will succeed. And so the pod will be assigned to the node where the reservation was scheduled. Now, I guess one thing here that is going to be that is still I didn't discuss like a lot, which is who's going to create the reservation. Maybe is that what make things a little bit unclear. So one thing that I had in mind was, again, like these like queue controllers or quota managers, they can benefit from this, or the controller that manages these spikes. Like it has, okay, I know when the spike is going to happen. I don't know, you schedule like a cron job that creates this reservation. And if you want to manage a group of reservations, and this is what I'm like suggesting to do here, which you could create a what I'm calling like a reservation set. It's basically like a replica set. It's a reservation controller that continues to make sure that you have an X number of reservations at a time with these specific labels. But again, another question is who's going to create the replication set, reservation set itself, and who's going to delete it? That is like, again, I think in my mind is some like this whole concept will be used typically by a resource manager that doesn't want to replace the scheduler, that doesn't want to replace any parts of kubelet. It just wants to make to take control over parts of the resources in the cluster. I mean, in a like, how do I say it, in an integrated way with the rest of the ecosystem in Kubernetes. Rob?
Yeah, so I have a couple of questions. I think you sort of mentioned about pod overhead, right? So you think the existing pod overhead is going to have problems because it is statically assigned and you want to make it dynamic. That's why you want to introduce a new API for this.
Pod overhead is, no, I'm not replacing pod overhead here.
Mm-hmm.
So
because
pod
that also
overhead,
actually, I think the goal here is to make sure that scheduler should take into consideration the X or extra amount of resources that are needed for pod. And one way to represent that is using pod overhead, right?
No, I mean, the idea here is that to create, to reserve resources before the pod is actually created. So before you actually create the pod, you want to reserve resources on the node for that pod.
I see. And like, you do not want to wait till the pod has been created. That is
Exactly. Exactly.
Okay.
You don't want to wait for the pod to be created itself. You want the you want to reserve the resources before that.
I see.
And
okay.
like, again, like the case that I mentioned, for example, now people use pause pods, right? In order to reserve that resource, they create a dummy pod with a pause control container that sits there on the node doing nothing but holding on to some resources that a future higher priority pod will take when it gets created, right? What the pause pod did is it basically triggered autoscaler to scale up resources, and basically made sure that there is a amount of resources on the res set aside for a future workload. And this is exactly the same, but you would have a lot more control over it because you can control which future workload that will be created can take these resources that are already reserved on the node. And you don't have to go through preemption. Like with the pause pod approach, the future pod will have to trigger a preemption, right? So you will have to delete the pause pod that existed in the node, and the future pod will have to go through 2 scheduling cycles to actually get scheduled.
Got it. So I think what you are trying to say here is you do not want those pods to be created and the pod overhead or the resources that are associated with the pause pod to be used. Rather, you want to have some sort of way to express that in future I may need these many resources, and I would like to reserve them now.
Exactly, right. And another use case here, imagine like you have this quota controller that says you can express in the controller, in the quota controller, that you have X amount of resources, right? And a job goes through that quota controller and says, okay, I have 100 cores available. I'm going, and I have a job coming in that needs 100 cores. Okay, I have enough quota. I'm going to allow the job to start. But in reality, you could, on the cluster itself, you can't make any guarantees that that job will actually get the resources, right? Because you could have other pods being created outside that quota controller that can take up the resources on the cluster. So creating these race conditions. So in order to harden the whole thing and make it more robust and give more guarantees over the resource management of the cluster, this reservation concept can give you that guarantee, because you don't need to give users the ability to create reservations. You just need to give them the permission to create pods. Them creating pods does not guarantee that those pods will get scheduled, because if you have a policy agent, for example, that says no pod can be created without a reservation affinity set, right? And so you as an admin, you can have these controllers that manages these resources, and you provide better guarantees over who can use what and at what time.
Got it. Two more slightly related questions. So say if you have a reservation and if it's not being used, is there an expiry time kind of thing after which the reservation would not be valid anymore?
Yeah, that's a good question. I think that was we discussed a little bit a few minutes ago, which is you could have modes of operation. You could either say, okay, a reservation should always exist, like it doesn't get deleted, because you could reuse it. The example I gave was a job with 1,000 completions but 100 parallelism, right? And so the job controller will have eventually to create 1,000 pods, right? But only 100 in parallel. Yeah. But those 100 in parallel can always reuse the same 100 reservations that you created initially. So that's one case. The other case, the other mode of operation, you could say, okay, the reservation life cycle is tied with the first pod that uses it. You could also say, okay, a reservation has, exactly as you mentioned, it has a, imagine that you're trying to optimize the cluster usage. You have a queuing system where users must define, their maximum runtime. And so you don't really need to go and delete the pods or have a custom integration with the workload controller to get the pods out. You can basically delete the reservation. And so even if the controller continues to create the pods, their job is not going to get scheduled, right? Because there's no reservation. So basically you can also control preemption using this approach, although a little bit ugly because the pods will continue to stay around unschedulable, but at least you get control over the resources. So that's basically two things that the reservation can offer you here, as I mentioned before, which is first, you can basically attach, by association, you can do scheduling, right? You can inject whatever affinities you want on the reservation, and so the future pod will just follow it without that pod having that affinity. The second thing is preemption. And those two properties would allow us to manage custom workload controllers without explicit integrations with that controller to introduce, for example, preemption or the ability to inject affinities into their pod spec, etc.
Got it. I have a few more questions. I think
Ravi, yeah, I
Yeah.
wanted to be mindful of, we have 8 minutes left. Swati has her hand raised for a bit. So I want to give her 3 minutes to answer the question. I would still want to give Aldo a chance to speak about the last topic in the last 5 minutes. So if you please try to fit in within 3 minutes. Go ahead, Swati.
Yeah, I think I have a quick one. So I see in the pod spec, for a pod that wants to use a specific reservation, we specify a match label, say like you have their foobar. Is there a way to specify a particular reservation itself, like by its name, or is it always going to be by a label selector?
I guess that is like, I would just, I mean, the canonical way is to set the reservation label selector, but we do have that reservation name here. The assumption here is that this would be set by the scheduler, so that you create that association, right? So that kubelet knows, okay, this for kubelet, and both kubelet and scheduler knows that these two things are one, so that we don't double count, right?
Right. And then in case of, say, reservation set, how that would be like assigned? Again, same way the scheduler assigns it, the reservation name.
Well, the reservation set is just a controller that makes sure that you have an X number of reservations objects. The scheduler would not be aware of the reservation set. It's just like it's not aware of the replica set.
Okay.
So it just maintains an X number of reservations. And
as part of the reservation set, all the reservations are going to be identical, or they could be different as well?
For in a reservation set, so we're proposing that you could have a reservation. I'm calling it bundle. Think of it as like the pod group, basically you could have like multiple templates, right? For each template, you create this number of replicas. I don't know if you can see my screen, but that I'm pointing.
I can.
Yeah. So this is the idea. So that, like, again, you create these, like, for Spark jobs, etc. You create one reservation for both the driver and the workers.
Okay. I was actually thinking maybe you've put some thought into, like, we are doing it kind of analogous to the replica set kind of framework. Have you thought about, say, maybe reservation classes? So we create a class and then pods could refer to those classes, as opposed to, because at this point in time, a reservation is tied to a pod and there's a one-to-one relationship. Whereas we could have like a class and many pods could refer to those kind of reservations.
I think this case is represented here, but can you please comment with this idea so that we can explore it more? I like the concept of a class in general. It groups things, and so it should simplify some of the things. But but it would be good if you can comment as well.
Sure, Aldo.
Thank you so much for your questions. I just want to give back last 5 minutes to Aldo and for the last item.
Yes, correct. If I share my screen quickly, and let's go back to the agenda and actually to the issue that Aldo brought up. Aldo, you want to talk about it?
Yes, just wanted to bring awareness of this feature request. We're basically waiting for people to give feedback on it. As you know, we recently introduced in 122, we introduced index jobs, which allows you to give a number to each pod in a job. And the request here is that we allow to also include which indexes you want to run, or the user wants to run. So instead of 0 to n minus 1, you do 1, 5, 7. And the use case here is that if you have a very big job, and it might just reach the backoff limit, and then some of the indexes completed, some of the indexes didn't, and you just want to finish up the job by running the indexes that fail. So that's a use case. One kind of open question is whether we want to include the failed indexes in the job status. Today we only include the completed indexes. And the use case would be, once we know it failed, we just copy and paste the list of indexes that failed into the spec of the new job. There are some performance considerations, or rather limitations in the storage that we need to take into consideration. So that's kind of like the contention there. And there is a slightly related feature request where we consider the backoff limit per index instead of for the entire job. So yeah, a few feature requests floating around about this feature. So I wanted to bring attention to people. Please comment if this is something that's useful to you, and if you're willing to volunteer to implement it, that's also welcome.
Yeah, I would like to, before we actually proceed with eventual implementation, I would like to hear more inputs with regards to what cases does this solve, which specifically. I don't feel like we need to expose the failed indices, because basically whether they failed or did not complete, you can easily calculate that by looking at what completed, and what is not in completed set means it either never started or failed, which basically means in both cases that you'll probably want to retry them. I'll be very cautious with introducing something like retries, with allowing users to pick and choose those indices. I'd be more curious about digging through why the job did not succeed for them, or what we could improve to make the job controller as it currently stands more reliable. Either, like you, Aldo, mentioned, by introducing the backoff per pod or some kind of tweaks around this, rather than allowing users to pick and choose the indices that they want to run. I'll try to comment there.
Right. So
I think sorry.
Go ahead.
No, I think one use case here is that like the failure might not be related to the job controller itself. Like imagine you're running an index job, and some of the indices you're working on that works on corrupt chunks that keeps failing the pod. And then the user will go ahead, okay, I fixes these things. Like maybe it's a wrong path to a chunk or something like that. And once doesn't want to restart the whole job, just want to, okay, let's continue with these indices.
Yeah, but then I would probably just try to figure out how we can identify those sooner than later and be able to react, as in fix those ad hoc problems while the job is running. So even if it would take longer to finish the job. I don't know, but yeah, it's fair use case, definitely. Okay, I don't want to take anyone any longer. We're already 1 minute past the designated 45 minutes. Thank you very much, all. That was a really nice talk with all the topics that we had today. See you again next time.
Thank you.
Thanks.
Yo.